The name of our experiment is grain size analysis by the hydrometer method. We cannot determine the grain size distribution for the particles by sieve analysis when the particles are finer than the number 200 sieve. That is why the hydrometer method is used when the soil sample contains more than 12% of particles finer than sieve number 200. This method is useful to further classify the soil in terms of grain size distribution. The required apparatus for this experiment are hydrometer jar, sedimentation cylinder, ASTM 152H model hydrometer, mixing pot, thermometer, soil container, mechanical mixer, balance, 125 ml cylinder, stopwatch. The materials used in this experiment are soil sample, distilled water, dispersing agent. Now let us come to the procedure of this experiment. At first, all the coarse fragments of the soil was separated out using a 200 mm sieve. About 50 grams of the fine textured material was weighed in the balance. Then this soil sample was placed in the mixing pot. 125 ml of sodium hexametaphosphate solution was added to the mixing pot. Tap water was added until the pot was 2/3 full. This produced a soil solution as shown in the figure. This solution was mixed for 3 to 5 minutes in the mixing device. The soil suspension was then transferred to the hydrometer jar and water was added up to the 1 liter mark. The water jar was also filled up to 1 liter mark. The palm of left hand was placed on the open end of the hydrometer jar and the soil water suspension was mixed by quickly overturning the jar up and down several times. Then the hydrometer jar was placed on the table. Care was taken so that the jar was not disturbed by any vibration. Immediately after placing the hydrometer jar on the table, the hydrometer was inserted in the soil water suspension. The timer was started and readings were taken at 15 seconds, 30 seconds, 1 minute and 2 minutes. After 2 minutes, the hydrometer jar was removed from the soil water suspension and was placed in the water jar. Taking hydrometer readings were continued at elapsed times of 4, 8, 15, 30, 60 minutes and 2, 4, 8, 16 and 24 hours. Between hydrometer readings, the hydrometer was stored in the water jar. The temperature of water was recorded from the thermometer kept in another water jar in the laboratory to the nearest 1 degree Celsius at the beginning of the test and at the time of each hydrometer reading from 15 minutes onward. With the hydrometer placed in the water jar, upper and lower meniscus readings were taken to find meniscus correction, CM. Usually, meniscus correction is 0.5, zero correction was taken to be 3.5. To obtain the zero correction, the same amount of deflocculating solution as used in the test is mixed with water and placed in a 1000 ml cylinder jar and hydrometer reading taken. The difference of this reading and hydrometer reading in pure water gives the zero correction CZ. Determination of particle diameter using hydrometer is based on Stokes' law. According to this law, the terminal velocity of a small sphere falling through a fluid is given by the equation V equals to gamma S minus gamma W into d square divided by 18 eta, where V is the velocity in centimeter per second, gamma S is the unit weight of soil particles in grams per cc, gamma W is the unit weight of water in grams per cc, Eta is the viscosity of water in gram second per centimeter square and d is the diameter of the particle. If the velocity of fall v is known, then diameter of the particle can be calculated from the following equation. Here is the datasheet from our experiment. Here is the particle size distribution curve. Percent finer is plotted against particle size. From the graph, it is obvious that the soil sample we used was poorly graded. This video was presented to you by students of Water Resources Engineering, Geotechnical Engineering Sessional Lab Group 2, Bangladesh University of Engineering and Technology.